Hello friends, this is part 2 of the getting this PRC-132 up and running. I really wasn't happy that much with the first video I made because I really should have shown you some of the work on the boards. And so I decided to make this part 2, might even make a part 3, we'll see. So first I wanted to point out that I mentioned to you that there is normally a hub, a hold-up battery that is usually soldered directly onto this. This is the CPU board. You even see it says processor board. Here's the CPU itself, NSC800N, which is a Z80 equivalent. And I have a few different versions of this of the firmware that I've saved from several radios that I've had access to. But in any case, you can see here there was a battery, and this is what I mentioned before. This is a little battery holder. It uses batteries, these batteries here, which is the CR2025. Just uses one of them. And what I did is I put a little hot glue here to keep, so that any wire stress on the wires does not break the strands of conductor. Instead, it puts the stress on the insulator of the wires. I don't know how well you can see that. Just a dab will do you. A little dab will do you. And on the rear, I put a little silicone stuff, and let it dry. And the reason is because I don't know if you can see this, but there's very little room between the back of the cards and this little metal separators between each one. I think there's like 30 mils, 0.03 of an inch. So in case anything were to touch, I wanted to have some insulation back here. And by the way, this is they did this with the coin battery that was soldered on. They also put some silicone here, so I think I did the right thing. The other thing I wanted to show is this is the first local oscillator board. And this used to be located on here. I think it was this orientation. And I desoldered it. Very easy to do with a Heiko 808 or equivalent. And you can see here that the pins really came out perfectly. And so this is where it would go. And what I did here is just substituted a lead, a yellow wire, where the output of this temperature compensated crystal oscillator would have gone, so I can inject my own 5.12 megahertz signal. So that's that. I'm going to reassemble it and continue the video and do another power test. Okay, just to pick up a little bit on this on the work we're doing here. So again, apologize for the noise, as we've got this big HP power supply. What I wanted to show you is the symptom. Whoops, if I can get rid of all these wires here. The symptom I was trying to solve for. Let's see if we can. Very annoying. Okay, radio is off. And what was happening is when you turned it on, if you can see the display, it says like 880888. And that's all that would happen. It was just really, let me see if I can get any better light on this thing. There we go. That's a little better. So I would turn it off and turn it on. And that's it. And there'd be no clicking, no relays, just dead. And this 88.0888, or all eights in some cases, is caused by two possible reasons. There may be more, but the two that I ran into was, number one, make sure you have a battery. And then number two, you have to have this 5.12 megahertz signal, which is creates the input clock to the CPU. So let me pause and set that up. Okay, so here what we have, this is the lead from the function generator with the 5.12 megahertz signal. Oh wait, hold on a second, I gotta turn that on, hold on. Alright, and we're gonna connect this up. Hopefully I can do this. I guess I should have done this first. So what you're seeing me do here is connecting this here. Okay. And now when we power it up, we get 10 megahertz, and you might have heard some relay clicking. Yeah, so that's if you have a PRC-132 that is not starting up and giving you all 8s in the display, look for either a bad hold-up battery, replace it, or on the A1, I'm sorry, I don't know the A number, but the board with the first local oscillator, look for the output of the of that temperature compensated crystal oscillator. And the next part of this is I just wanted to also show, do another round of power tests, but this time using, instead of sideband, where you're always trying to produce a whistle to produce some signal. I've wired up the input, the handset input for the CW key. So CW works in any mode here, upper sideband, lower sideband, AM. It'll always produce something. And so I thought we would go through the process and look at the power output. That way you get a better signal. So I'm going to put this on 5 watt power, and then I'm going to put this on 5 watts. And all I'm going to do is short these 2 wires together, and we'll see the power output. So we're expecting a 5 watt output, this is 6, that's 5. Yep, we get a full 6 output. In fact, I just wonder if there's anything, if it's putting out more than that. Oops, I have a hard time. Okay, so yeah, it's about 6 watts. Okay. Let's increase this from 5 to 10 watts. And we'll do this again. 10 watts should be here. And 10 watts, just a bit over 10 watts. Increase this from 10 to 20. 20 is here. Yep, almost between 20 and 25 watts. And then the last, we'll put it on 50 watts. And let's see what we got. 50 is, we'll have to move this to the higher setting, to 150 watts. And 50 is right there. And there we go, a little over 50 watts. And by the way, this is a 12 volt radio, so at 50 watts output, it's putting out at 12 volts, it's taking about 10 amps. So that gives you an idea. That's 120 watts to get 50 watts out. Gives you an idea of the efficiency of the radio. Okay, that's pretty much it. I think I'm done with this. Thanks again.